So we use two-way frequency tables to figure out probability of B given A. So we use the tables to figure out our favorable and our total. Well, we can use a formula to find conditional probability if we know the probabilities of each part. We know the probability of B and A, so we can use a formula to find our probability. So we're going to call that our conditional probability formula. Our conditional probability formula is to find this probability of B given A if we know the probabilities of the parts. So the probability of B given A equals the probability of A and B divided by the probability of A by itself. So we have two parts here. We have to know or be able to figure out the probability of A and B, and to find an AND probability. What did we do with the parts? Multiply. AND probability was multiply, and then we divide by the probability of A. So notice how the formula works. This is probability of B given A. We calculate the probability of A and B happening together, divided by the probability of the given part. And it's important to know that the probability of B given A is going to be different, doesn't equal the probability of A given B. We'll get two different probabilities, usually. So the probability that someone owns a car, given that they own a house, is different than the probability that someone owns a house, given that they own a car. The two probabilities are different. Because lots of people own cars who don't own houses. Usually if you own a house, you also own a car. Usually. So these, if we switch the order, they're going to be different. So let's look at let's look at a calculation using this formula, and then we'll talk about a shortcut. A way that we can just a different way, not necessarily a shortcut, but a different way that we can work with this. All right. So we're working with a medical company, and we're testing the effectiveness of some kind of medicine. So we have a certain number of people that we're running this test on. Half the people got the medicine. And half got a placebo. What's a placebo? Sugar pill. Right. It looks like the medicine. They say it's the same as the medicine. So it's something that it's not actually medicine, but the people think it's medicine. So that's what a placebo is. So they want the people to think that they're actually taking the medicine. So half the people got it, half the people didn't. The probability that a volunteer got the placebo and got well, was 20%. So we want the probability, now we want to find the probability that any person got well, given that they received the placebo. So part of these probability problems is kind of decoding what they're asking us. So I'm going to write down a few probabilities just to make it easier to see what we have. So probability that someone got medicine. So what's the probability that someone in this test got medicine? Half, or 50%. And the probability of a placebo. %, again. So I'm trying to use less words. I'm going to say probability of well and placebo. So that's the other thing that we have here. So what's the probability that they got well and got a placebo? 20%. So what we are looking for, we want probability of well given that they got the placebo. Well, we have the probability of medicine, probability of placebo, and we want the probability that we have the probability that they got well and they got the placebo. We want the probability that they got well given that they got the placebo. So let's look back at our formula. This says the probability of B given A is the probability of A and B divided by the probability of A. So for our example, our given is that they got the placebo. So we're going to be dividing by the probability of the given. So let's write the bottom here. So the given is that they got the placebo. So what's that probability? 50%. We'll write that as a decimal. 0.5. And on the top, the probability of A and B. So what's the probability that they got well and they got the placebo? 0.2. I divide that out and I get 0.4 or 40%. So I found the pieces of my formula and then use the parts that I needed. The probability that they got well and they got the placebo was 20%. The probability that they got the placebo was 50%. So little bit tricky, but not too bad if we just find our pieces and then look at our formula and figure out what pieces of the formula we have and where we need to put them. Something that we can do when we have probabilities listed this way is use a tree diagram to help us out. Now before we move on, do we have questions on this example? So we're going to talk about tree diagrams. Tree diagrams are a nice way to show these probabilities when things can happen in more than one way. So here's another kind of problem, similar to the one we just did, and we're going to use a tree diagram this time. So we have some kind of sports team. And the sports team wins 65% of games on mud. So on a muddy field. I'm just going to say games on mud. And it wins 30% on dry fields. Probability of the next game being on mud is 70%. I guess they're predicting a lot of rain. I don't know how you get that probability, but the net probability that the next game is on mud is 70%. So we want to know the probability that they win the next game. Well, we can draw a diagram to help us out here. So our team can play in two different ways. On a muddy field or on a dry field. And on a muddy field, they either win or they lose. And on a dry field, they win or they lose. Now what does the problem tells us? They win 65% of the games on mud. So this branch, if they play on mud, this branch is 0.65. They have a 65% chance of going on that branch. Well, they can only play in two ways. So these two branches have to add up to 100%. They either win or they lose. So they have to add up to 100%. So if this is 65%, what would this branch be? 35% or 0.35. These two have to add up to 100% because they either have to win or they have to lose. The problem tells us they win 30% of their games on dry fields. So 0.3 on that branch. So what does this branch have to be? 0.7 or 70%. They have to be 100%. The probability that the next game, here's our game. The next game is on mud is 70%. So where am I going to put that 70%? Probability that the game is on mud is 70%. And what does that mean, the probability that the next game is on a dry field? 0.3, 30%. Have to add up to 100%. To find the probability that they win the next game, knowing that there's a 70% probability that they play on mud. So to find the probability that they win if they play on mud, we multiply along the branches. So this would be probability that they play on mud and win. We multiply along the branches. So probability of mud and win is 0.7 times 0.65. We multiply that out, and this gives me 0.445. Is that the only way they can win? They can also win if they play on a dry field. It could happen that way. Probability of dry and win multiply along that branch, 0.3 times 0.3. So I'm going here and here for this one, and I'm going here and then here for this one. So when I multiply this out, I get 0.09. The probability of a win in any way, I just add those two together. So I have the probability that they win on mud or dry. So either one, I'm adding them together. Add those two together, and I get 0.535, which is about 54%. So if we draw a tree diagram, on any branch our possibilities have to add up to 100, and then to find a probability moving along a branch, we multiply the probabilities. So we're finding the probability of mud, that we play on a muddy field and we win. We multiply. Probability of a dry field and we win. We multiply. And then in the end we add the probabilities together, because we're finding the probability of winning on a muddy field or a dry field. So those two, they can't happen together, so it's an or probability. Questions on that example? Okay, let me draw a tree diagram for the first example we did with the placebo and the medicine to show how the tree diagram is related to what we did before. All right, so we did some kind of test. In the test, the people either got the medicine or they got a placebo. And the problem told us what percent of the people got the medicine? Half. And the other half got the placebo. And then there were two possibilities here. they were well, or they either got well or they did not get well. And we have two possibilities here. The problem didn't tell us anything about how many people, what percentage of people took the medicine and got well. It only told us about the placebo, people who took the placebo. And I'm going to put not well here. And well. We had the probability that they took the placebo and got well. So the probability of this whole branch that they took the placebo and got well was 0.2. And it says we wanted the probability of this branch, the probability that they got well given that they took the placebo. So we were finding, put it here, we were finding this branch. To find an and probability, we multiply. So we know that 0.5 times question mark equals 0.2. We multiply along the branch to get the entire probability. So question mark was 0.2 divided by 0.5, which is what we did in the other problem. So in the other problem, they gave us this entire branch. And we had to find this piece. All right, questions? Okay, homework for tonight. There you go. I will